Yes, students, as I said before, you are supposed to complete the assignments. Still, many students are there, they are not paying interest or not doing the assignments. It is not expected. Purpose to provide you the video lectures was that you should study at your ease. I understand at that particular time, say 2 to 3, everybody may not get the range or the network or maybe not suitable to attend the online lecture. Then at least by going through the video lectures, maybe recorded video lectures, online recorded and already recorded lectures, but you are supposed to study is your role. And for that, if you have any doubt or any question, you are free to ask. I'm not saying that only remain present in the online lecture, live lecture, and there only you ask. Other time also you can ask. But your desire should be there. Your interest should be there to learn. One thing I make very clear. After your theory examination, there will be practical examination. I will conduct experiments also. That work you have to complete. That is the journal. Along with that, students who have completed assignments, see assignments, these assignments for lectures, and plus the simulation experimentation, what I will complete. That work also will be there. What that work will be there, afterwards you will come to know. Combination of that will be your journal. And if you complete that work, then you will be allowed to appear for examination. Which examination? Practical examination. College is allowing you to appear for theory examination despite of my reporting, because those who have not completed reporting is there. Okay, it is their part. I can't interfere there because it is not my jurisdiction. That HOD, principal and admission committee will take the decision. For me, attendance means your assignment completion. Plus these live sessions are there, that's additional. But for practical, being a teacher in charge, I can ask you that complete the work, be a student, be a regular student of F.Y.B.Sc SRM college, then I can conduct your examination. I'm there to conduct your examination. But without being a student, I can't. You should be a student. Only take an admission means you are not a student. You should be regular. It is my expectation. And about this, repeatedly instructions are given. Repeatedly. And polling also done from you. I ask online to many students. Is it fair? Whatever I expect that assignment completion should be there. Am I wrong anywhere? Likewise, the feedbacks were also taken. And from that conclusion was yes, assignment completion should be there. So again, I inform to those, especially who are not regular to complete the assignments, please complete the assignments. I'm not here to punish anybody. I'm here to encourage everybody to learn the chemistry, work for the chemistry, work for the brain development, work to know the life, understand the life, and live the life to the fullest. These are skills, and these are the one of few soft skills, few hard skills are there. And by this learning, considerable amount of the soft skills you can develop. But your tendency should be there, no? It is my expectation. Therefore, students, I am appealing you to complete the assignments. And after your theory examination, whatever the practical session I will conduct, remain present. Because without remaining present, without that the demonstration, suppose if you go on doing it, it will be the most hectic task. Actually, you have to do that task. So you should learn that. And for learning, your attendance is expected. Because in examination, you have to perform. Your camera will be on and you will be working there. And for that, if any doubts are there, any problems are there, I am here to help you. But your curiosity, your interest to learn, to work is most important for me. Once again, I am taking poll or the feedback. Yes, students, whoever are present here, do you agree with my view? 13 students are present here. 38 students are there in F.Y.B.Sc. Out of that, 13 are present. Okay, I understand, but at least assignments you have to complete. Am I wrong anywhere?
No, sir.
No, sir.
No, sir.
No,
No,
sir.
sir.
Yes. Yeah. Thank you for response. Now let us come to our understanding of the paper 1 unit 2 topic. That's the atomic structure. You might have prepared the notes. So at the beginning, historical perspectives for the atom that I covered. It's a Thomson model, a plum pudding model, or I labeled it as, yes, which fruit it is?
Watermelon.
Right.
Water. Hmm.
Watermelon. So positive portion is the red flesh and the seeds are the electrons. It's a Rutherford's experiment. Rutherford's famous alpha particle scattering experiment. From that one model for the atom we sought out. It is with too many limitations. Electron will lose the energy and electron will merge in the nucleus. Then the Bohr's theory, then how development took place. So historical development completely is covered. Then atomic number means what, mass number means what, how to find. Now then Bohr's theory. For that, all videos are prepared, right from the historical perspective, right from the days of Kanad to the modern approach, modern electron cloud model. I had a discussion. Then the energy calculation, radius calculation, numericals also are discussed in the video. Sometimes for homework in that, numericals are given there. Few students might have answered, especially last year and before that students, whether they have answered, meticulously they have answered. This year, I not made that compulsion. But I expect that you have to work for that. It's a spectrum for the hydrogen. Why do we find that's a Balmer series? That's alpha, beta, gamma, delta, those lines. Their calculation is expected. Structure of hydrogen is a part of your study in that all series, right from the Lyman series to the Humphreys series can be discussed. What are the limitations of Bohr's theory? Then principles of the quantum chemistry, fundamental basics. It was started with de Broglie. So lambda is equal to, yes, what's the equation for the from the de Broglie equation? That's a de Broglie concept. Lambda is equal to, yes, I represent it. At least read and tell me. Lambda is equal to,
H upon MV.
right. That's a de Broglie concept. So there somewhat we got the clear-cut idea about the matter wave. So the difference in the electromagnetic wave and matter wave concept will be clear. There one function will be there because these are mathematical approaches. Function will be there. That wave function is represented psi, and that wave function psi can be described by means of these four variables: small n, capital, sorry, small n, small l, ml, and ms. Will anybody help me? What is that N, L, ML, and MS? Those are
Quantum numbers.
Quantum number.
right four quantum numbers. So that wave function divided in two parts, one orbital part and other spin part. Orbital part which involves this N, L, ML, and spin part means only MS. That's a spin quantum number. That was due to the Dirac's concept. Then Heisenberg uncertainty principle. Importance of that Heisenberg uncertainty principle. Why electrons are outside? Why not inside in the nucleus? Or why protons are inside? Why not are outside? Scientific reason is provided by means of the Heisenberg or Heisenberg. Then particular energy levels. That's a principal quantum number, shell number, their energies. Calculations as per the Bohr's concepts are done. Then the concept of shells, subshells, and orbitals can be discussed. Then electron spin concept, that's the intrinsic property. Radial shapes of the various orbitals. Yes, radial shapes are there. S orbital, p orbital. Near the nucleus, especially for the 1s orbital, more electron cloud will find. As you move away slowly, electron density will be feeble, less, and the electron will not be there. It's for 1s. But if you come to the 2s orbital, at the beginning, little electron density will be there. After a gap will be there, white portion are finding. So gap, that's a node, radial node. And then the slowly electron density will decrease at the 2s region. It is the pictorial presentation. We can represent them graphically also. And that graphical representation is here. That's a 1s orbital is represented. Then 2s orbital is represented. Here you will find where it touches to the x-axis. That is a zero electron density. That is a node point. Then you can understand 2p orbital. There is a no node because first p orbital, no, it is 3s orbital. Two nodes are there because it is not the first orbital. 1s was the first orbital, 2s was the second orbital. Now 3s is there. Okay. Likewise, number of nodes you can find, radial distribution you will understand. So actually, maximum radius is one concept, and the average radius R bar is other concept. So radius concept will be other clear. Angular shapes, s orbital how spherical symmetric, p orbital how it is a dumbbell in shape. D orbital how made up of the two dumbbells, but various d orbitals also are represented. If we consider many electron system, then shielding and penetration videos are also there, and in detail also points are discussed with you. So what that actually the screening or what the shielding concept that diagrammatically is explained. Effective nuclear charge, that's a Z effective is equal to Z actual minus S. Z effective means effective nuclear charge. Z actual means is atomic number. And S, what is that S? Will anybody answer? What is that S? Effective nuclear charge is equal to Z minus. Right, shielding or screening constant. Constant. Last time in lecture, I had given you one separate term. What was that? Effective nuclear charge is equal to Z minus or Z star is equal to Z minus.
Shielding constant.
What was the term for that? Here S is there.
Series constant.
Yeah, shielding constant. Yeah, screening, shielding. Okay. Term, notation for that. Representation.
Later.
Sigma.
Right, sigma was a representation. Sigma or S by which screening constant is represented. It's a Bohr principle. Electron plane takes place from low energy orbital to the high energy orbital. Different energies are what? Represented. Then the second bit, that's a periodic table and periodicity. 18 groups are there, 7 periods are there, how elements are arranged, why we say is a long form of the periodic table. Few examples here. I had quoted classification of elements in 3 parts: main group, transition, and inner transition elements. Effective nuclear charge concept, which was there in the previous bit. Again, it is here, and that I discussed last time. Effective nuclear charge, Z star is equal to Z minus sigma. Last time was given. Now here you are finding S as what the notation. Different rules we have discussed and we applied that. Examples I had considered. I had given one homework also. That's a copper. Yes, have you worked for that copper 3D electron? Yes or no? Did you work or not?
No, sir.
Okay. Further 2 replies I want. No, then say no, no problem.
No, sir.
Yes. Any one more reply at least.
No, sir.
Okay, no issue, but you have to work. You can, because as you solve the more problems, concept you are the more clear. But I hope and expect that concept is clear. Application of Slater's rule is clear to you. Variation of atomic size. As we move from left to right, size decreases. Reasons also are what they given. As we move from, okay, here what happened? Those previous diagrams are a mix, but only pay attention towards right side. There you will find size is what increasing as we move from top to bottom. Reasons are given. Then electron gain enthalpy. How does it vary? Why does it vary? Electron gain enthalpy means electron affinity. Similarly, if you come to the halogen family, in halogen, fluorine, chlorine, bromine, just you see negative sign is there because energy is evolved or absorbed. When will negative sign? Enthalpy change evolved. Yes, enthalpy change negative energies evolved. And you will find surprisingly for chlorine, more electron affinity is there than that of the fluorine. It was expected fluorine should show the large electron affinity, but it is not. 349 is a large number compared to 328. Reason for that is the small size of the fluorine. Actually, it has that ability, but because of its small size, whatever the 9 electron family is there, those 9 electrons are crowded. Those are closely arranged. So whichever the 10th electron is coming in F minus experiences repulsion relative to chlorine. Actually, attraction is there, but relative to chlorine, repulsion is there. Therefore, more attraction is not there. For what? Fluorine compared to chlorine. Therefore, we find that chlorine is with the more electron affinity in the halogen family. I repeat, fluorine was expected to show the more electron affinity or electron gain enthalpy, but chlorine is showing that large electron gain enthalpy. Reason is the size of the fluorine, small size of the fluorine. Then ionization enthalpy or ionization potential, about which also I had discussion. How does it vary and why does it vary? Again, the issues are there with that the previous diagrams. Now we have discussed the electronegativity concept. This electronegativity depends on size. Because of that, see, when I was talking about the variation of atomic size or ionic size across a period for fluorine, some difficulties were there. Why that much decrease is not there for the fluorine? I think Vaibhavi, you were with the doubt. Concept was not clear, but Manthan was there. For Manthan, the concept was what the clear. At that time, when I said electronegative fluorine is large, electronegative fluorine is large and high, therefore it is shrinking. Therefore, size is what the decreasing. And there the concept become what the more clear. But actually electronegativity depends upon what the size. Yes, students, are you following what I'm saying?
Yes,
Yes, sir.
sir.
Yes, sir.
Yes. Actually, base point is size. When I said the wrong thing, it was appealing to you. You understood that. But actually, basic thing was size. On the basis of size, electronegativity varies. Size is a one of the factor. Don't say that only the factor. Then electronic configuration, then enthalpy of ionization. Therefore, those things are discussed first, and then electronegativity included in your syllabus. Then different methods are there to determine the electronegativity. I want to discuss the first method now, Pauling's method for determination of electronegativity. That Pauling thought that electronegativity can be calculated on the basis of dissociation energy. Means what he considered. Just pay attention now, or it is better that I should open the Google board. Just wait, just wait. Give me a time, please. Yes, could you able to see the board now?
Yes, sir.
Yes, sir.
We're talking about now Pauling's method. Pauling's considered three types of molecules. It's three molecules actually, not types. Actually, two types only are there, but three. One AA, other BB, and third one AB, and that's the experimental part. What he considered here in these first two covalent compounds, homonuclear diatomic compounds, and last whichever the molecule he considered, that is the heteronuclear diatomic molecule. Bonding is there everywhere. You may find here is a one bond, here also one bond, here also there is a one bond. Bond is there. But suppose if you decide to break that molecule, if you decide to break that bond, what do you think? You need to provide energy or energy will come out? I want breaking. I want to break the bond. I want to rupture that bond. What shall I do? Shall I provide the energy?
Provide energy.
We have to provide.
I have to provide energy. Let me say energy for this necessary to break is E1. For BB molecule is E2 and AB molecule is E3. Now E1 and E2 covalently bonded compound and their bond breaking. E3 ionic character is more compared to the covalent compound E3. What do you think? E1 and E2 are with the one value and E3. That value of E3, that's in case of ionic compound or compound having more ionic character. That's E3. This E3 will be more than E1 and E2 or less than. What do you think? Because of the ionic bonding, the molecule becomes strong or weak? What is your just concept, understanding at this moment?
Strong, sir.
E3 is less than E1 and E2.
Yes. Add one more answer. See, here two different answers I am getting. One is saying E3 is strong, other is saying E3 is weak. E3 is less. At least one more answer. Yes?
3 is strong.
Right. A and B two are there. Electronegativity difference. Suppose B is electronegativity, then B will bear partial negative charge, and A will bear the partial positive charge. Because of that partial charges on A and B, there will be the additional attraction, and that additional attraction gives more stability, and because of that more stability, bond strength remains larger. Because of that bond strength, more energy we have to provide. Means what? E3 is larger than E1 and E2. Yes, students, are you getting this point, what I'm saying?
Yes, sir.
Yes. Same Pauling considered. What Pauling did, AA means both have same electronegativity. BB means both have same electronegativity. But AB means one has one electronegativity and other has other electronegativity. So electronegativity difference, because of the electronegativity difference in the or increase in the bond energy will be there. And by trial and error, by experimentation, he brought out the one concept that the difference in that energy we can relate to the difference in the electronegativity. So what he considered, EAA, that's the E1 value in my discussion, is a bond energy for A molecule. EBB, bond dissociation energy for BB molecule. EAB is a bond dissociation energy for AB molecule. Let me consider this symbol. Yes, anybody can read or anybody can answer what's the name of that symbol or how to pronounce that? Highlighted. Is it readable? That symbol was likewise. What is that symbol? Here in this way. This symbol is called
Psi.
not psi. Psi means
Theta.
no. Eta means this. And like theta means this. That angle measurement that you might be knowing. Season ball. Yes. This symbol I want. Help me. At least read now.
Chi.
It is called Chi.
Chi.
Means pronunciation is chi. So chi A, let it be the electronegativity for atom A, and chi B be the electronegativity of for the atom B. It is consideration of the Paulings. Then difference in the electronegativity, chi B minus chi A. Students, I want to know, could you able to read that equation?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. That difference in the electronegativity chi B minus chi is equal to 0.102 square root of, what is in square root? EAB minus further square root is there. And in that second square root or sub square root, what is there? EAA dot EBB. It's a multiplication of their energy. And if you solve that, then you will get the electronegativity of the electron difference. So energy EAB practically determined, EAA practically determined, EBB practically determined. From that, you will get the difference in the electronegativities. Now, if you know the difference in the electronegativities, then how to find the particular electronegativity? Yes. Will anybody help me to write the formula? What is that formula? Chi.
A.
It's a chi B minus chi A. I am considering B is a electronegative, more electronegative. Okay, different. Okay, is equal to. Yes, what's the answer? One number was there. What was that?
0.102.
102.
Brilliant. See, this is the way of memorization. Square root of one energy was there.
E A minus B.
Okay, it's A minus B. No, it's a EAB. It's a EAB. AB molecule it is. It's A, not A minus B. Read that as AB molecule. For showing bonding, dash is there. Are
Okay,
you following what I'm saying? Okay. That's a
Yes.
EAB molecule. Yes. Minus or plus?
Minus
Minus. Square root of.
square root of E
Right.
A minus A
Right.
minus
Into
Into
EBB.
what?
EB.
BB. Okay, this square root, and it's a large square root. We could get from this difference in the electronegativity. That's a chi B minus chi A. Sorry. If we know difference, then how can we find the particular electronegativity? For that, somewhere we have to fix, even in EMF calculation, electromotive force or potential or voltage calculation. You might have studied primary standard. Hydrogen electrode was a primary standard. Then secondary standards, maybe glass electrode, maybe one cell also you might have studied. Calomel cell, Calomel electrode, Daniel cell. Are you understanding what I'm saying?
Yes, sir.
Yes,
So
sir.
always for measurement, some standard is to keep. Even now we weigh the particular entities. If you go to the grocery shop, then we take 1 kg, 2 kg material. On what ground that's a 1 kg? Somewhere gram is fixed or kilogram is fixed. From that they have converted. If you go to the cloth shop, then in meter they measure the cloth. On what ground that's a 1 meter? Somewhere it is fixed. Even liquid, if you have to measure, petrol you have to measure, you will measure in some liter. On what ground that quantity is only liter? Somewhere it is fixed, and it will be fixed. Then uniformity will be there. Measurement will be proper. So for that electronegativity also, we need to fix electronegativity of at least one. If we know electronegativity of one, we can find out the electronegativity of the other. And what Paulings did, Paulings considered electronegativity of hydrogen. He considered in electrode potentials, it is considered electronegativity of hydrogen electrode zero. Sorry, electromotive force, EMF, or you can say electrode potential, E naught value. Standard reduction potential for hydrogen, 0. Likewise, electronegativity for hydrogen, Paulings has considered is equal to 2.05. Few books you will find it is equal to 2.1. Sorry, 2.05 or 2.1. Anything you can consider. That somewhere it is fixed. Once it is fixed, once we know electronegativity of one thing, we can find out electronegativity of the other thing. Means what I mean to say. If I consider HCl as a molecule, then difference in the electronegativity, that's a chlorine, minus electronegativity of hydrogen. But if I know, say, electronegativity of hydrogen as 2.1, and if I know the difference, say X value, I can find out electronegativity of chlorine. That's the idea of Pauling. So what Pauling did, by trial and error, he worked and he has given one formula for us to calculate difference in the electronegativity, provided those electronegativities are measured in terms of kilojoule per mole, because joule, calorie, these are units for energy. If calorie measurement is there, then quantities or values will change. Then our factor, that 0.102 coefficient will change. So that 0.102 coefficient is there if we measure the energies in terms of kilojoule per mole. So provided energies are measured in terms of kilojoule per mole, it's SI unit, electronegative difference will be this much. And electronegative hydrogen is fixed as 2.1. Yes, is it clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Here I had given one example. See, HCl molecule for previous discussion. Here HF molecule is considered. For HF means AB. Bond dissociation energy is 569 kilojoule per mole. For hydrogen HH, it's an AA molecule. Bond dissociation energy is 436 kilojoule per mole. For fluorine FF or BB molecule, energy is 157. So we know energies. Just those values are substituted here in this formula. We got difference in the electronegativity should be equal to 1.8. But we know already electronegativity for hydrogen is what? 2.1. So hydrogen's left side and minus sign is there. As it comes to right side, the sign will revert, will become plus. So electronegativity of fluorine is 3.9 as per Pauli's scale. As per reference changes, these values will change. Considering data, which of this data is there, this value. So 3.9 or 3.9 or 4, that's electronegativity of fluorine as per Pauli's scale. So with one example, this electronegativity measurement by means of Pauli's method is made clear. So what is the conclusion? In Pauli's method, what we emphasize, on which we have given the importance, yes, Pauli's method is there to find difference in the electronegativity. And which point was considered here? Formula is there, but what is the main point? We considered which energies we have considered?
P into A.
No, formula I don't want. I want name of that energy.
Bond in.
Bond
Dissociation energy.
right, bond dissociation energies we have considered here. So with the help of bond dissociation energy, variation in the bond dissociation energy, electronegativity difference can be calculated. And what Pauling said, that difference in electronegativity is equal to, yes, help me number point.
0.102
Yes, 102
square root of EAB
right,
minus
right,
square root of EAA into
yes,
EAB.
EBB.
BB.
Okay, good. So is that Pauling's method clear?
Yes, sir.
Yes, sir.
Good, very good.
Yes, sir.
All you are brilliant.
sir.
Now let us understand Mulliken's concept. See, 1934 means just century also not completed for this concept. Completely new concepts are there, but they have changed the chemistry. They have changed the understanding of the science. Yes. What Mulliken considered, since both ionization enthalpy and electron gain enthalpy is a measure of ability of atom to pull electron. Means in case of ionization enthalpy, we provide energy. And in case of electron gain enthalpy, energy comes out. After all, it is related to the affinity of that electron towards nucleus. So both are somewhat related concepts. That idea Mulliken has used to find the electronegativity. I repeat, what I am saying, ionization enthalpy means removal of electron, energy needed, enthalpy change. Electron gain enthalpy means addition of the electron, energy evolves. That's the enthalpy change during that gain of electron. So those are after all related to what? Related to the attraction between nucleus and the electron. With this idea, Mulliken has put forwarded his formula. What he said, let chi m, m for material that he is using, any material, is the electronegativity of one particular atom, and delta H for ionization enthalpy, that's a delta HIE, and delta HEG. Yes, will anybody answer? H for what? H for what here?
Enthalpy.
Right, enthalpy. Delta for what?
Change in enthalpy.
Brilliant. Change, difference. And EG for what?
Electron gain enthalpy.
Right, right. Electron gain means EG. IE means ionization energy. Like for terminal difference only that I represented. Of course, those energies He wants to consider in kilojoule per mole. Let it be the ionization or let it be electron gain. Then formula for electronegativity will be this one. Read it carefully. That's chi m, that electronegativity is equal to 1 upon 2 into 96.5. 2 into 96.5. I am repeating 2 into 96.5. Previously 102, 0.102 was there. Now 96.5. Those numbers are somewhat related to century. That was above century, as a less than century. Less, but consider less. So it's a relation. I'm playing with those numbers. So that will help me to what? Remember. In bracket, that's a enthalpy change for ionization and enthalpy change for electron gain. Now question you will be with, why had I represented two separately? I could have multiplied that, no, directly, and I would have represented that, and that answer will be almost is the 193. But why two separately represented? Because he has considered arithmetic mean, different geometrical mean, arithmetic mean, harmonic mean, you might have studied. Likewise here I am talking about arithmetic mean, simple average concept. Average, two things are there. How will you find average? Summation of those things divided by 2. Summation is in bracket and divided 2 is represented separately. It is a formula for Mulliken's calculation. Yes, I need your help and please complete the formula. Yes, electronegativity for say particular atom M is equal to, help
1
me,
upon
1 upon
2 into
2 into 96.
right here 2,
96.
whatever the number came, that 2 number came because of average. 2 into
Average.
number was 90.
96.5.
5. Brilliant. Those who are working, certainly it will be easy for them to what? Remember. How much time I spent? Maybe 1 minute or 2 minutes we have spent. When you will work at your own, 1 minute is more than sufficient. But as you remember the values, joy remains. Just answer for my question. Don't you think memorization is enjoyable? Now whatever you did, memorization, you remembered and you said, is it not enjoyable?
It is enjoyable, sir.
Yes, other students, do you think it is interesting?
Yes, sir.
Yes.
Yes, sir.
When you will work, no, then it is interesting. If you do not work and you expect you have to remember, it is a very trouble-taking, very pain-taking process, insulting process, de-respecting process, and we ourselves insult. It's a great thing. Actually, it's a very bad thing. Okay. In bracket, what was there?
Change in ionization enthalpy.
Yes. Enthalpy change delta H for ionization. Plus enthalpy change for
Electron gain.
electron gain. Good. It is a formula suggested by Mulliken. Let me complete it. Energies are expressed in terms of what? What are these energies are there? What is unit for that?
Kilojoule per mole.
Right. Kilojoule, mole inverse or per mole. Likewise, you can read that. Brilliant. Okay. Here, example of fluorine is considered. Electronegativity of fluorine. Because previously we also found electronegativity of fluorine as per Pauli scale. What was the answer previously? Electronegativity by Pauli scale, what was the answer? Anybody remember?
Kilojoule per.
No, answer. Electronegativity of fluorine. Answer, final answer. Electronegativity of hydrogen, we consider 2.1 for Pauli's method. For fluorine, it was, after calculation, it was 3.9 or 4. We are consider 4. Listen now. 4 was electronegativity. And here by formula, ionization enthalpy was represented here for fluorine, electron gain enthalpy, then substituted those values. See, electron gain enthalpy was considered in bracket. Bracket means modulus bracket. Positive values are considered there because average was considered, no? Positive, considering positive value, amount, point of view, it is considered. Okay, so answer for electronegativity of fluorine is 10.4. It is different. It is different for Pauli's method and 10.4 by Mulliken's method. Okay. So in case of Pauli's, let me come to our Google board. In case of Pauli's method, point of interest was bond dissociation energy. In case of Mulliken, interesting point was, yes, by which point we considered enthalpy
Change in
or ionization and
electron gain.
Ionization energy you can consider and electron gain. Okay. Now let us come to the next concept. That's a Rochow concept. Alfred Rochow theory. Alfred Rochow method for determination of electronegativity. What?
Sir,
Yes, please.
sir, we have practical exam of math now.
At what time?
3 o'clock.
Oh, sorry. And then I stop now. Then when will you come again? So what I do, I share this file in the Google Classroom. So this only last method, one formula is there. You can go through that formula and you can work. I don't want to disturb your examination. I
Okay,
stop
sir.
here. Okay. And if doubts are there, then in a group you can bring one time. I'll what come next Monday or Tuesday. I can have the further discussion. You can ask me. Is it clear to
Okay,
all?
sir. Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes.
Okay, thank you everybody for information. Okay, now I declare here today's session is over. If any doubts are there, we can have the further discussion later on. I stop the recording, quit now.